figure here, listen or look at your notes as I read the definition of a parabola. It says, a parabola is a set of all points in a plane which are equal distance from a fixed point and a fixed line. All the points. Now look, if I take this point, it's the same distance to this fixed point as it is to this fixed line. I'm taking points as they move. This point, this point, this point, this point, this point. These points along this curve are always the same distance from this point that's not moving as it is to this line that's not moving. This fixed point is called the focus point. This fixed line is called the directrix line. So the definition of a parabola is all the points, or the path that all these points make, such that the distance from any point on the line to that fixed point is the same as the distance from the point on the line to the fixed line. Well, let's put some xy's in here. We're going to let this point, any point along here, be xy. Now, if we want the distance from this point to this line, we have to go perpendicular, which means I don't care whether it's here, it's going to be perpendicular. So whatever this x is, this x is going to be the same. So I'm going to have x here, and I'm going to have the same x right here. This focus point is up so far. We'll just call it A, distance of A, just some distance. The directrix is going to have to be A, the distance from here. This is called the vertex right here. The distance from here is also going to have to be A, because it says is the same distance to the focus point as it is to the line. So that says this is going to have to be distance of A also. So that makes this line down here, y equals minus A. And that's the directrix line. All right, let's look at the formula that we know. The distance from here to here is the square root of x minus x squared plus y minus the y squared. Well, that square root, looking here, the square root of the x minus the 0 squared plus the y minus the a squared is equal to this distance. Now, this distance is the x minus the x, that would be 0, y minus the y. All right, looking at that, we get then the square root of x minus x, that's 0 squared, y minus a minus a, which would be y plus a squared. Now, square both sides. These are equal, remember, that's the definition of parabola. Squaring both sides, we get rid of the square root sign, and we have this. And then squaring all this out, we have x squared, this squared out, it would be y squared minus 2ay plus a squared. This squared out would be y squared plus 2ay plus a squared. Now watch, a squares drop out, y squares drop out, and we have left x squared. Moving this across this side, we have a plus 4ay. And this is the general form of a parabola, now listen closely, of a parabola, looking at the figure, such that the vertex is at the origin of the x, y axis. Let me say it one more time. This is the general form of a parabola, such that the vertex is at the origin, and the parabola is opening upward or downward. Now, we'll look at some more cases here in a minute about this, but here's the general formula. One of the letters is squared. It's either x squared, and then over here, it's something times y. We could have had y squared something times x. Now, let's learn about this something times x bit. What's this 4a bit? Well, what is A? A is the distance from the vertex to the focus point. A is the distance from the vertex to the focus point. Let's go back and look at the figure again. That's what A was. A was the distance from the vertex to the focus point. Don't forget that. A is the distance from the vertex to the focus point. Also, looking at that figure, A is the distance from the vertex to the directrix line. A is the distance from the vertex to the directrix line. All right, let's look back now underneath this equation and go through these four things. The vertex in this problem was at 0, 0. The focus in this problem was at 0, A. The directrix line is y equals minus A. That's directrix line, not the dime. And then the lattice rectum. The lattice rectum is 4A. Now let's look back at the figure and learn what that is. The lattice rectum is this line that goes through the focus point perpendicular to this axis, to this line that this parabola is symmetric to. So it is this line right here. So that says this is 2A distance and this is 2A distance. Okay? That's the lattice rectum. Through the focus point, okay, like this, and that total distance from here to here is 4A. All right, now let's look at 4 examples. Let's look at x squared equals 8y. X squared equals 8y. Let's graph that, all right? Now this is in the general form where the vertex is at the origin. So here is the vertex of the parabola. It is x squared, therefore it's opening upward or downward. Well, how do I know? Here's how I know. 2 ways. First of all, the general form of a parabola is x squared is equal to 4ay. Well, 4a equals 8 in this case. 4a equals 8. That means a has to be equal to 2. That means, since this is the vertex, a is a positive 2, so I come up this far 2 units. So this would be 0, 2. This, of course, would be 0, 0, the vertex. All right, so here's the vertex. Here's the focus point. The directrix line is down 2. So it would be y equals to a minus 2. The lattice rectum is this 4a. It's just this number. So the lattice rectum is 4 this way and 4 this way. And so here, then, is the parabola drawn. So this point would be over 4. It's still up 2. That's how far it was here. This is over 4 this direction, be minus 4, 2. And I have drawn now the parabola. Now, I want you to notice these things. What I'm saying to you is, here, first of all, if we take whatever this constant is and divide it by 4, we've got how far it is from the vertex to the focus point. And at that point, we can then take this total number 8 and go half this way, plot those 3 points, and plotting the vertex and these 2 points, we can draw the parabola. We can sketch it. All right, let's look at the next example. The next example is the x squared equals to a minus. Now, it makes a difference whether it's 8 or 16 or what, but it's a minus. What happens there? All right, the vertex is at 0, 0. Now, the focus point, 4a is equal to the minus 8. So a is equal to a minus 2. That means we come down 2 for the focus point. That means this curve is going to go this way. Okay? The directrix is up 2, so we have y is equal to 2. The last rectum is this total distance. Now, forget about the minus now. That minus was helping us on the focus point. All right, so this is out 4, out 4, plot those, and we have the sketch for the parabola. Now let's look at these two together. What I want you to realize then is this. Memorize, 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 memorize. X squared equals something y is a parabola either upward or downward. If it's positive something y, it's upward. If it's negative something y, it's downward. Let me say it one more time. If the x is squared, the curve is up or down. If it's positive y, it's up. Negative y, it's down. Okay? That goes along with, then come back in. See, the first thing you should realize, if you have an x squared, then you picture up and down. If it's positive y, then it's up. Then you come along and say, okay, this is the form where the vertex is at 0, 0. Divide 4 into that, that's how far it is to the focus point. Take that total distance, go out this way, and there's your 3 points, and you plot any parabolas you have. That's the quick way of graphing a parabola. All right, let's look at the next two examples one at a time. We'll look at this one now, where y squared equals to 4x or 16x or 24x, whatever this is. All right, so graph this one. It's in the form where the vertex is at the origin. Now, y squared, y squared, y squared says the curve goes left or right. So if the y is squared, the curve is opening to the left or opening up to the right. All right, we divide 4 into this. 4 into 4 is 1. So over here, the unit of 1 is the focus point. So over here at 1 is the focus point. That means if this is the focus point and that's the vertex, then the thing has to curve like this. Well, how much does it curve? Does it curve like come in here like this, or does it curve way out here? That's where we use the latus rectum. The latus rectum is 4, so from here we go up 2 and down 2. And it happens to be then this parabola. So this point is 1, minus 2, and 1, 2, and 0, 0. And the directrix line is x equals a minus 1. X equals a minus 1. The focus point was 1 unit, so the directrix is 1 unit from the vertex. Now, I hope you listen to me and listen to all these little conditions, because we're going to get to where we put this parabola off somewhere else. The vertex is not going to be at the origin. But we're still going to use the same concept of this is A, and A is 4 divided into this number. This distance is A. This distance is the 4A, or just whatever number you have in the equation. All right, let's look at the next example. We have y squared equal to minus 4x. That says the vertex is at the origin. Dividing 4 into a minus 4, we get a minus 1. So we're going over this direction. So that says the curve is opening up over here. How much? Well, 4 units. So we go up here 2, we come down 2, and we have the parabola y squared equals minus 4x. The directrix is over here. X equals, in this case, x equals 1 because this is minus 1. This distance is 1. This point would be a minus 1, minus 2. This point would be a minus 1, 2, as you have in your notes. Now, back off and look at all 4 of those again on your notes. There that you have it at the bottom of that page. What I want you to realize is if the x is squared, it's up and down. If it's positive y, it's up. Negative y, it's down. Look over here at these two on your notes. If the y is squared, it's right or left. If it's positive x, it's opening up to the right, back this way. If it's negative x, it's opening up to the left, back this direction. Now, if you don't get anything else out of this tape, you don't forget that, because you deal with parabolas over and over and over again in calculus and other mathematics. One of the most common and most used equations. And you need to have that concept down. All right, let's continue then looking at at example 1. Example 1 says, write the equation of the parabola whose vertex is at the origin and focus point is at -3, 0. That's all we're given. Well, now we're given a whole lot from that because of this. If this is the vertex and this is the focus point, then the thing has to come back like this. So that says y squared equals something times x. Well, what is this something times x? Remember, it's 4a. How much is a? Right here. A is the distance from the focus point to the vertex. That's 3. 4 times that is 12. And it's negative because it opens up this way. Another way of doing it is just what's 4 times a -3? That's -12, and you get it. And that's all there is to it. If you know what the 4a is, if you know which letter is squared and which letter is not. Okay, example 2. These are all fairly easy if you're understanding the idea of the 4a, the y squared, the x squared bit. Example 2 says this. Write the equation of the parabola with the vertex at the origin, okay, and the directrix line is y plus 4 equals 0, or y equals to a -4. That says this distance from here to here is 4. Well, the distance from the vertex to the directrix is the same as the distance from the vertex to the focus point. So this would be 0, 4. Aha, we know A. A happens to be 4. So, now, the vertex is here, the focus point is here. That means the parabola has to open up this way. That says x squared equals, well, x squared equals what? Something times y. What is that something times y? It's 4 times the distance from the vertex to the focus point. So that would be 16. And we have that one. Now, as I'm saying again, this is all there is to working most of these, but it's simple concept. If you understand up and down bit, x is squared. Left or right bit, the y is squared. Understanding what this 4a stands for. All right, now let's look at example 3. Example 3 says that the vertex is at 0, 0, that's origin, and the lattice rectum is a distance of 6. And it opens to the right. Well, now, let's see. The vertex is here, and it opens to the right. So that's this way. That says that y is squared equals something times x. Well, the lattice rectum is 6. There it is. We got it. That's done. And that's all there is to writing that one. Now, if we want to go ahead and finish graphing it, where's the focus point? The focus point is divide 4 into 6, which would be 3 halves, 1 1/2. So this would be out here 1 1/2, 0. Just to come up with the equation, though, that's all we need. All right, now let's look at the next concept, and it's the most important, well, at least as important as anything else. And this statement is, what happens if the vertex is not at the origin? We still keep the 4 conditions, okay, where x is squared equals 4a times something y, then that opens upward. X is squared equals minus something times y, that's downward. The y squared equals something times x is opening to the right. The y squared is equal to a minus something times x is open to the left. Now, what I want you to notice then is simply this. What this h and k is the vertex of the parabola. In other words, if I have x minus 2 parentheses squared is equal to 8 times y minus 1 parentheses, then I have a parabola which opens upward since the x is squared. Its vertex is at the point plus 2, plus 1. So on the graph, we would come over here a plus 2 up a plus 1. It opens upward, so the curve would look like this. Now, all we're saying then is this h and k bit throughout these 4 different cases is the vertex of the parabola. The vertex of the parabola. We're not changing any other concept in. Okay? Let's graph a couple of problems. Let's say right over here we have y equals, x minus 4 squared equals 16 times y plus 1. All right, graphing that says that the vertex is at plus 4 minus 1. Plus 4 minus 1. There's the vertex. The x is squared, so it's opening upward. Okay, so it's opening upward. It's like this. 4 into the 16 will go 4 times, so we come up here 4. That's 1, 2, 3, 4, and there's the focus point. We go out here 8. We go out here 8, and we have the parabola then. X minus 4 squared, y plus 1 times 16. The vertex is at 4 minus 1. The focus point is 4. The lattice direction is 16. And there we have those points, and we graph it. Now, if we're going to fill this in, let's learn how to do this. If this point is 4 minus 1, this point is right above it, so that's 4. But now it's 4 up, so 4 up from minus 1 is a plus 3. Now, it's 8. The lattice direction is half here and half here, so it's 8 out this way. From a plus 4, 8 would be minus 4, 3. And this would be 12, 3. And that's where that comes from. And so this has the same concept as all that work before. The only difference is right here. If you have these numbers in here, then you move the vertex from the origin. You move it somewhere else, and then from that vertex, you go up or down to the focus point, left or right to the focus point. And then wherever that focus point is, you go perpendicular to that between the focus and the vertex to draw your lattice rectus. All right, let's look now at example 4 in your notes. Example 4 in your notes says that we have a parabola whose vertex is at the point 2, 3, and whose focus is at the point 6, 3. Write the equation of it. Well, let's see. The vertex is at 1, 2, x is 2, y is 3. So here's the vertex. The focus point is at 6, 3. So we come out here 3, 4, 5, 6, 3. Aha. If this is the vertex and this is the focus point, then the curve has to be like that, which says y, okay, squared equals something times x. Well, now, y minus, what is the y value? 3. So it would be y minus 3. X minus, what's the x value for the vertex? 2. So it's y minus 3. The y of the vertex, the x of the vertex. And then it's 4 times a. Well, what is a? A is the distance from the vertex to the focus point. And that's a distance of 4, I'm sorry. This is 2, 3. This is 6, 3. So the distance from here across to here is 4. So 4 times 4 would be 16. Remembering this number right here is 4a, where a is the distance from the vertex to the focus point. Or 4a is the distance to the lattice rectum. All right, so that's all there is to writing this equation. But you have to know some things. You have to know which letter is squared and which letter is not, by whether it's opening up or down or left or right. And you can tell that thing by plotting some of these points. If the vertex is here and the focus point's here, then it's upward. If this is the vertex and this is the focus point, then it's downward, and so on and so forth. All right, looking at example 5. Example 5 says that the vertex is at the point 3, minus 2. The ends of the lattice rectum are minus 2 1/2, 8 1/2. So let's just plot that and we'll get a good picture of what's happening. Plotting 3 minus 2 and minus 2 1/2 and 8 1/2, that says this thing is like this. There's the curve. So that says x is squared and the y is not. It's opening up, so the x is squared. Now where's the vertex? The vertex is 3 minus 2, so the x minus 3, y minus the minus 2 is y plus 2. All right, what's the lattice rectum? The ends of the lattice rectum is from here to here. How far is it from a minus 2 over to a plus 8? That would be 10, and so this would be 10. Remembering that 4a is the length of the lattice rectum. And so we have the equation x minus 3 in parentheses squared equals 10y plus 2. Now, let's do something on this. Let's just go ahead and square all that out and look at what happens. Squaring this out then will be x squared minus 6x plus 9 equals 10y plus 20. So getting everything to one side, we have x squared minus 6x minus 10y minus 11 is equal to 0. And so that's the final answer. Now what I'm saying is in the back of the book, a lot of times when they give you these problems to work out, this is what you'll see in the back of the book. So you don't stop at this step down here. You go ahead and work all that algebra out and come up with this. Now, the previous set of problems, the previous chapter that you dealt with was circles. And you had an x squared and a y squared. Notice in this one, you'll only have one of those two letters squared. So if you only have an x squared, it's a parabola. If you only had a y squared and not an x squared, it's a parabola. All right, let's look now at example 6. Example 6 says sketch this one. Now, let's go back and look at what we just got through coming up with on example 5. Our final answer on example 5 was this. Look at the similarity between that final answer and example 6. What we've got to do then is work backwards. Let's look back at example 5. Example 6 says, I'm going to give you this. You go back this way. You come up with it like this, and then from here you sketch. The vertex is here and here, focus point, blah, 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 blah. Okay, so what we're going to do now is be given this and learn how to bring it back to that form so that we know whether it opens up or down, left or right, where the vertex is, where the focus point is, and so on. All right, let's look now at example 6 and do that. This is by the method we use in circles. We have to complete the square. X squared plus 4x. Leave a space. Move the y to the other side. 16y minus 4. Now listen, if I know it's a parabola, then I get my square terms, those letters, in this case the x's, on one side, move the other letters and the constant to the other side. And see, you didn't do that on circles. You kept everything on one side, all the letters. But now, when it's parabolas, you get all the letters, one kind of letter on one side, all the other letters on the other side. Now complete the square. Remember, to complete the square, you divide this by 2 and square that, and that's what you add to both sides. And so we have x plus 2, parenthesis squared, 16y. Now graph that. Well, the graph of that, very simple. The vertex is where? Now, 16y is the same thing as 16 times y minus 0, isn't it? So the vertex is at x equals minus 2, 0. Minus 2, 0. So here's the vertex. Now, the x is squared. The x is squared. Therefore, that's opening up or down. Since this is positive 16, then it's opening upward. Therefore, my focus point is 4 up. So the focus point is at minus 2 plus 4 for y. This is minus 2, 0 for y. Now, where's the lattice direction? The lattice direction is 8 in both directions. 16, so it's 8 this way. Okay, this is 2, then 8 would be about here. So this would be 6, 4. Okay. From minus 2, we're going to go length of 8 units. So from minus 2 over here, 8 would be to a plus 6. We're still at the same level as this one, so the y is still the same. And so we have the parabola opening up like this. Now over here, we go 8 this way. Now going 8 this way, this would be a minus 10, 4. And so we have the parabola. The directrix, remembering, if A is 4, then this is 4 also. So this would be y equals to a minus 4. And now I have sketch, and this is what your teacher will require on a test when they say sketch. They will want you to tell them where the vertex is, minus 2, 0, where the focus point is, minus 2, 4, where the ends of the lattice directions are, and the equation of the directrix line. All right, let's look now at example 7. Now, before we do example 7, let's look at an extra problem here. I don't have any notes, but I'd like to work through one more of these completed square concepts just to help you out maybe on understanding it. What we have then is y squared minus 6y plus 10x minus 1. We keep the y squared on one side, leave a space, move the x's across and the constant. And now we need to complete the square here. Dividing this by 2, we get 3. Squaring that, we add 9 to both sides. And so we have y minus 3 squared is equal to minus 10x plus 10. So I'm going to factor a minus 10 out, and that will give me x minus 1. So I have y minus 3 squared is equal to a minus 10 times x minus 1. Now let's graph that. Well, graphing that, the vertex is at 1, 3. So we come over here at 1 and up 3. So the vertex is here. Now let's go through. We know the vertex, H and K. Step 2. What letter is squared? Well, the y is squared. Therefore, it's opening up left, right. Which one? This is the concept of the 4a. The minus 10 is equal to the 4a, where a is the distance from the vertex to the focus point, and also the distance from the vertex to the directrix line. So, we divide whatever this constant is out here, we divide it by 4, and that's the distance from the vertex to the focus point. So dividing this by 4, we get 2 1/2, 5 halves. So we come over here 2 1/2. Now remember, we came over here 1, so this distance is about 1, 2 1/2. So this is the focus point. This is the vertex. All right? Now, ends of the lattice rectum. The length, the total length of the lattice rectum is this constant, 10. Forget about the plus and minus, 10. So that says that this will be up 5 and down 5. And so our parabola looks something like this. The directrix line will be over here, x equals something. Well, this point, remember, is 1, 3. X is 1. The distance is 2 1/2. Remember, A is 2 1/2. 4A is equal to 10. A is equal to 2 1/2. So we come over here 2 1/2 from 1, which will make that 3 1/2. And so the equation of the directrix line is x equals 7 halves. I hope that's sufficient then in terms of graphing parabola. 3 things you need to know. Number 1, what letter is squared? If the x is squared, then it's up and down. If the y is squared, then it's left or right. If this is positive, then it's up for x. It's this way for y. If this is negative, it's down for the x. It's that way for the y. All right, number 2 thing. This number right in here, what does all this number represent? That number represents 4A, where A is the distance from the vertex to the focus point and the distance from the vertex to the directrix line. So, whatever that is, if you divide it by 4, that tells you how far to go from the vertex to the focus point, or from the focus point to the vertex. And number 3, that number, as it stands, just 10, is the length of the lattice rectum. The total length of the lattice rectum. All right, let's look now at example 7. Example 7 says this. We want to find the parabola that passes through these 3 points whose axis is horizontal. Now, the general form of a parabola. The general form of a parabola is x squared plus bx plus ey plus l. It's x squared plus something x plus something y plus a constant. Or it's y squared plus something x plus something y plus a constant. One of those 2. Now, how do we know which one it is? Axis is horizontal. What does that mean? Axis is horizontal. Well, since the axis is horizontal, that means it had to be this way or this way. So that means if it's opening up right or left, it's y squared is equal to the dx plus ey plus l. See, we'll have to be given something in the problem that tells us whether it's opening up left or right or up or down. If it's left or right, it's the y squared equals dx. If it's up or down, it's x squared is equal to. Okay? All right, let's finish this problem then. We have given then that the form of this parabola is going to have to be y squared plus dx plus ey plus l. The problem says that it goes through the point minus 1, 1. Well, remember, what are these points? These are x's and y's. So I will put this y everywhere y is. That will be 1 squared. X is a minus 1. Put a minus 1 right there. Y is 1. Put a 1 right here. So we have the equation D, E, and F. Now let's take the point 3, 4. If I take the point 3, 4, y is 4. So I put a 4 here. That would be 16. X is 3. Put a 3 right here where X is. That's plus 3D. Just a minute. Let me see if I've written something problem down. Looks like I'm supposed to have a minus 3. Now this is a plus 3/4. Okay, so this is a plus 3D. All right, y is 4, so that's plus 4e. Plus F equals 0. All right, it also is going through the point 2 minus 2. I put the minus 2 everywhere y is. That's minus 2 squared, that's 4. X is 2, so I put a 2 where X is. That's plus 2D. Y is a minus 2, so I put a minus 2E. Plus F is equal to 0. All right, now, looking at these three equations, we have then minus D plus E plus F is equal to minus 1. 3D plus 4E plus F is equal to minus 16. And 2D minus 2E plus F is equal to a minus 4. Now, you solve those simultaneously. Okay, go solve that. However you go through it, either determinants or adding and subtracting, eliminating letters. But you come out then, if I haven't made a mistake somewhere, you come out with D is 18, E is 7, and F is 10. Now, go back to, look back over here, go back to the general form of the equation and put in the 18 for D, the 7 for E, and the 10 for F. All right, let's look what we have then. We have y squared plus 18x plus 7y plus 10 is equal to 0. Now we go through our completing square that we've done in the last three problems. This would be x squared, y squared plus 7y, moving 18 across and the 10 across. All right, completing the square here, dividing 7 by 2, squaring that 49/4. Adding that is 49/4. All right, this then will be y plus 7 halves squared. And this will be minus 18x. Let's see, this would be minus 40 plus, it would be 9/4. Factoring it 18 out, or minus 18 out of that, we would have x plus, okay, factoring 18 out would be what? Oh yeah, I'm factoring a minus here, so it makes this a minus. Makes this a minus here, excuse me. So this is a minus. All right, factoring 18 out of here, I would have to have 4 times 18 would be 72. So it'd have to be 1/8. Okay? Let's check that. 18 times 1/8. 18 times 1/8 would be, divide 2 of this will be 4, and this will be 9/4. So factoring 18 out of this would have to be 1/8. That says then, we have a parabola, y squared minus 18 is our 4a, and the x over here. So the graph of that then looks like this. The vertex is at 1/8 minus 3.5, minus 7/2. So it's way down here. That's the vertex. The y is squared, and it's a minus 18, which says it's going back this direction. Minus 18 divided by 4 is minus 9/2. So we go back here 4.5, and that's the focus point. We come up then, so far 9 units up here and 9 units down here, and we have our parabola. All right, let's look at a couple other examples. All right, let me do one other problem. This is not in your notes, just another problem similar to some of your homework problems. This problem says write the parabola such that the axis is vertical, its vertex is here, and it goes through this point. Now, first of all, vertical. Axis is vertical. That means it's up or down. So that tells us that x is squared and y is not. Okay, the x is squared and the y is not. The vertex is at -1, -2. Minus a -1 and minus a -2. So we can fill that in. This is the thing we don't know. So we'll just put our 4a there. We don't know what it is. We just put 4a and have to solve for it. Now let's go through this again. Anytime a problem says it passes through the point, then these are the numbers that you plug in for the x's and the y's. So we get to plug in 3 for x and 6 for y. So plugging a 3 here and plugging a 6 here, we end up with 4 squared is 16 is equal to, this is 8 times 4 is 32a. So a is equal to 1/2. What's 4a? 4a then is equal to 2. A is equal to 1/2. 4 times 1/2 is 2. Therefore, our equation is x plus 1 squared equals 2 times y plus 2. And this is basically how simple it is in writing parabolas. If you know what these things are, this is the vertex, and if you know what this idea of which letter is squared. If it's up and down, x is squared. If it's up, this is positive. If it's down, this is negative. And we know then the concept of parabola. This then concludes the tape on parabola.